2 hours class அப்புறம் கிளாஸ் எடுக்கிறேன். Okay. Good evening, one and all present here. This is Saravanan, PhD scholar and Prime Minister Research Fellow of Department of Civil Engineering in National Institute of Technology, Tiruchirappalli. So, as a part of PMR of deliverable, I'm taking this NPTEL course. I'm assisting this NPTEL course, Municipal Solid Waste Management, which was handled by Dr. Ajay Kalamdad sir from IIT Guwahati. And every week I'm taking 6 to 8 this NPTEL problem solving session. So, this session will go in two parts. In the first 1 hour, we are going to discuss the same lecture material what sir has discussed in the class, and the next 1 hour we are going to discuss the old assignment problems and the MCQs. Okay, so this is the seventh week. We are going to see the lecture, and in the first 6 week we have discussed about what is the solid waste and what are the types and classification of solid waste on the basis of different sources, and then how to handle the waste at the storage place and how to segregate the waste, and then different functional element we have discussed on the solid waste management that I'm going to show here. Yeah. Yeah, how the waste get generated, how to handle the waste, and how to store the solid waste. And then the first one is the primary collection, how the collection was happened in curb and early collection, early storage, and how the waste is collected primarily. And then secondary collection in the bigger vehicles we have discussed stationary container system and the hauled container system, and we had some problems solving session. We have analyzed the systems and all, how it's working, and what is the number of trips we can able to do in a day, and this are all we have discussed, and we have compared to collection systems also. And then we also discussed about the transfer station, MRF, material recovery facilities, and then transport and transfers we have discussed. Then process, in the processing we have discussed about the physical processing like shredding, segregation, magnetic separation, and then baling, compaction, and all we have discussed. And then transformation in the sense volume reduction, or chemical transformation, or instead of physical, what are the things we can do like chemical transformation or biological transformation we have discussed from last week onwards. The first biological transformation method is composting. So in composting, what are the factors affecting composting and what is composting? And in composting, we have three main methods. One is like, sorry, two main methods. One is open, another one is reactor type. In open type, we have two things. One is static pile, another one is agitated pile, that is windrow. In reactor type, we have horizontal flow, vertical flow, and batch reactor type. So last week we have discussed about what is windrow, and in static pile, how we are going to aerate the sample and all we have discussed. Now we are going to discuss about the reactor type composting methods, that is horizontal flow or vertical flow or batch type reactor composting, and also the vermicomposting in this lecture. Okay, yeah. So the reactor type is called in-vessel composting, as we have discussed earlier. So composting have two things. One is open and closed. Closed in the sense reactor, that is in-vessel system. Why we need to go with the in-vessel system? What is the purpose of going to in-vessel system instead of normal windrow or open composting? Because the area required for open composting will be huge, and in countries like cold regions, we can't adopt this type of open composting system because whatever this weather condition like winter and rainy season, this cannot be possible to do composting. So in-vessel composting will be secured, and it will reduce the land area. Also, the process will be very quicker. So that is the thing we are so that is the thing we are going to discuss in the in-vessel composting. Okay. So open composting, there are some disadvantages like area requirement and seasonal issue that we are going to handle with the in-vessel composting systems. So in in-vessel composting, it is majorly based on how we are aerating. It will be and also based on the flow of the feed. So if the feed is flowing in a horizontal direction, that is called horizontal flow in-vessel composting. If it is flowing in a vertical direction, then it's called vertical flow composting system. If the flow is not happening, only we are keeping in a batch, and after the compost got ready, then we are going for the next batch. Then it is called a batch reactor type composting system. Okay, these are the types of in-vessel composting system. So it's also based on the flow and also based on aeration through bottom or through top, how the aeration is going to happen. So these are some of the pictures showing how the in-vessel composting is happening. Okay, then what are the configuration, reactor configuration in the in-vessel composting? One is horizontal drum, vertical silos, and also the open tank. These are the three configuration we can go. It may be a horizontal drum, we can see here, that is a plug flow horizontal reactor we will say, because there is a flow, that is a material that is going to be composed, maybe a food waste or a vegetable waste, any organic waste we are feeding, that's the feed. So that is after feeding, it's moving 40 days or 60 days, the matured compost is coming out from the other end. So it is called plug flow horizontal reactors. Okay, so here there is a hydraulic ram that will push and it will again pull. There will be a space for the feed. In vertical type, that is plug flow vertical reactor or vertical xylos we will call. Xylo, the word we will use for cement storage tanks also. In cement manufacture, if you are a civil engineer, you know, in cement manufacturing, after the manufactured cement will be stored in a big drum structure that is called silos. So the same terminology we are using here, that is a vertical silo. In this, the compost, the material will be, that the organic feed will be poured from the top of the silos, and the matured compost will be extracted from the bottom of the tank. So here the aeration is happening throughout the composting tank in horizontal type. From the bottom, from first to the end, it will be happening, and then the remain whatever the other gas that is extracted from the right side. So the inlet is happening at the left side, and the outflow of the air is happening at air removal. This is air distribution. This is air removal from the right side. But in xylos, the air is getting in through the bottom, and the other gas or the air removal through suction, it may be happening from the top. So it's mixing with it's mixing everywhere through the composting material. That is called vertical reactor. So another one is like open reactors. So in open reactor, the air is passing throughout the compost, and after some time the whole material was taken out and then new material will be fed. That is called a batch reactor kind of. Okay, so here you can see a conveyor belt is there, so that will convey the composting material into the tank and air will be supplied. So it may be horizontal, open horizontal rectangular tank, or vertically mixed reactor. So there is a vertical auger. You know what is called a auger boring. If you are a civil engineer, you know what is auger boring. A screw kind of thing will be used to bore the ground. The same thing we are using here, auger type for mixing the compost. So this type of vertical reactors will be there with this type of blade augers to mix the material. The final compost will be taken out. Another one is like this is a rotating horizontal drum. So here also you can see a drum. The feed will be through the top, and then the drum itself will rotate, and then the final material will be coming out through the other end. After some trommel screening is important for the matured compost, because any compost when it is matured, it should be less than 2.36 or 4 mm to be used as a soil amendment. So proper uniform size is required to be used as a fertilizer or soil amendment. For that we are using trommel screens. Trommel screen is nothing but a drum having pores. So if you are feeding the compost, based on the size it will fall down. So if it is less than 4 mm, it will pass out. Whatever greater than 4 mm will be passing through the other end of the trommel screen. I will show you some of the photos of the trommel screen in the upcoming slides. So this is one type of rotating drum, rotating horizontal drum type reactor. Okay. So here you can also see some of the aeration bed, and then after maturation bed. After the compost is ready, we have to keep some time for maturation. After maturation, we can separate some of any magnetic material is there, because we are going to keep it in the agricultural land. So there should not be any contaminants like trace elements. So we have to do magnetic separation. After proper screening, the matured compost will be sent to the markets. So this is another type called xylos or tower reactors. So xylos or tower reactor, in which each day the auger moves the compost material from the bottom, and the aeration will be happening from the bottom of the tank. Here you can see that one. So the auger will take out the compost from compost out, and then the aeration is also happening from the bottom. Okay, and then the secondary, there is a two reactor kind of things also there. One type, a single reactor xylo towers also there, and then two reactor xylos will also be there. In that first this growth phase and the active phase will be happening in the first reactor, and then maturation will be happening in the second reactor. This type of two reactor system also we can follow. So in this you can see, after leaving the first xylo, the compost is cured in the second aerated xylos. So that will reduce the time and also the space required for composting. Then this system minimizes the area needed, and also the material can be stacked vertically. So you can also see this. After first thing, the material will be passed to the bottom tank, then the compost material will be taken out, matured compost will be taken out and stored separately. This type of vertical stacked system also we can follow. So the stacking also present compaction, temperature control, airflow. These are the three major things we need to maintain. Temperature we need to maintain, airflow we need to maintain, and the compaction to reduce the space required for composting. Okay, this is one type of in-vessel drum composting. You can see here a rotary drum composting provides agitation, aeration, and mixing of compost. Here the drum itself will rotate. You can see here instead of mixing through auger, the drum itself will rotate in a slow motion, like 2 rotation per minute. That is very slow speed. So like that, the whole tank will be rotating, and then the final compost will be taken out through this end pipe, and the feed will be happening from that top at another end. Okay, so this will give you a consistent and uniform end product, because everything is rotated at a same speed. So whatever the product we are getting will be consistent and uniform end product we will get. So another one is like if it is having some warm and moist environment, because it's a closed in-vessel system, so it will have some warm and moist environment. So it will make the aerobic microorganism to flourish and decompose the waste at a quicker phase. That is the principle behind this type of in-vessel composting. So we are maintaining the ambient condition, optimum condition, that is warm and moist environment for the aerobic microorganism to flourish and decompose the waste at a quicker pace. Okay, then the rotating drum again, we can say the rotating drum configuration, it will be horizontal and the diameter will be around 3 meter. You can see 3 meter means how much big it will be, the vessel will be, and then length will be around 40 meters, that is 36.58 meter long, and capacity will be, yeah, ma'am, you want to ask something? Sorry, sir.
Sir, I yes, sir. Good evening, sir.
Yeah,
Sir,
please.
your voice has been like striking, sir, from that time. So it isn't in a continuous flow. I guess there is an internet lag from your side.
From which slide actually am I lagging?
Sir, previous, sir.
Okay.
Yes, sir.
Is it fine now?
Yes, sir. Yes, sir. Yes,
Sorry
sir.
for that. I
Still,
will continue from this slide again. Sorry.
yes, sir.
Yeah.
Yes, sir.
Thank you so much. In vessel drum kind of thing. So you can see the whole drum itself will be rotating. So the purpose is to produce consistent and uniform end product, because all the material will be rotated at the same speed, and the whole drum will be rotating in a speed of around 2 rpm. That is very slow speed, and whole material will be mixed instead of auger mixing. The whole drum itself rotating, it will give you a consistent and uniform end product. That is the ultimate aim. And also, this universal composting will give you an optimum environment for the microbial growth, because it is a closed environment. So it will maintain the warmth and the moisture inside the tank. So this warm and moist environment will help the aerobic microorganism to flourish and decompose the organic matter at a quicker phase. So this is the thing you can check here. uh, what are the components that should be present for a drum composting system? Okay, so the configuration of the rotating drum is shown in this slide. You can see it's a horizontal drum having a diameter of around 3.35 meter, a bigger diameter drum, and having a length of around 40 meters, 36.58 meter. uh, it will have a daily capacity to handle 50 tons. So 50 tons of waste is like a centralized as a decentralized system. The whole sorry, it's a centralized system for the whole municipality. We can collect 50 tons of organic waste and we can give, and the residence time is 3 days. So once in a 3 days we can handle. So 3 days by 50 tons by 3 days, it will be around 20 tons per day. If the village or a town is having the generation rate of 20 tons per day of organic matter, then we can go with this type of universal composting. That is another disadvantage of universal composting, because it can handle only smaller quantity instead of if you are going through windrow or open type composting, we can have a huge space, and it will handle around 250 tons or 350 tons of organic waste, because it's open area only, na. So but drums have capacity constraint. That is one of the important disadvantage. Okay, another one is in the drum composting, it is like advantages, it's quicker because of the warmer and moist environment, and it can also have different compartments. First stage will have in one compartment, and then second stage. First stage is like growth phase and active phase, and the second one is like maturity phase we can have in the second stage of composting. Usually in windrow and aerated pile, it cannot be accomplished. It should be turned every time, but you can do this type of compartments in universal composting. Okay, and then air supply you can do in the opposite direction. Whenever the compost is coming, I mean the feed is coming through this way, the air supply will be from the opposite direction. If it is coming in the vertical direction from top to bottom, then the air supply will be from bottom to top. Then only the mixing will happen properly. Okay. You can see some of these diagrams here, the rotary drum and then section view, and then what is the inlet feed, and then out that product, that is the compost here. So the drum can be open or partitioned. Like partition also we can do for first stage and the second stage, and it should be a continuous flow. And it may be batch reactor or a continuous. Rotating drum will always be a continuous system. Okay, and the speed of retention and the inclination of the axis determines the residence time. So usually it will be around 3 days residence time. So the inclination will give you the speed of the material to travel and come to the outlet, and then the speed of rotation and the inclination of the inclination, that is the axis of rotation. Okay, so it will have a slight axis of rotation. Then only the feed will come out through the other end, that by gravity. In some commercial system, the composting material spend less than 1 day also. That is like a factory made or a factory scale, industrial scale we can go. And temperature diagram, as we know, it will increase first. Why it's increasing? Because after growth phase, during active decomposition phase, the temperature will increase and it may reach up to 70 degree also, and it will kill all the pathogens, and the major active microbes will be in the form of endospores. And then after active decomposition phase, it will again come down to maturity phase. It will come down to the ambient temperature, that is around 27 degree or 27 or 26 degrees Celsius. It will come. Then the endospore will again become active. So this is the phase we have discussed in the last session about composting process. So here also we are going to discuss the same. In the in-vessel composting, the temperature may go up to 28 degree and then it will reduce in the third day. After rotation, it will go and again it will reduce. So this is called a rotating bioreactor and a static bioreactor. The same temperature it may happen, but the temperature changes around 0.3 degree and 0.2 degree here. So that's the difference. Here another models. You can vary the model of composting as per your wish. And these are the success models we are discussing here. One of the thing is like Ohio University's universal composting system. Here you can see whatever the food waste material, we are having a paddle that will rotate and throw the waste. So here while throwing itself, we are aerating through pipes. So that will give you a lots of contact area to the for oxygenation and air contact, and then it will be sent to the first compartment. Again, the air also flowing through all the pores through the bottom of the tank. The matured compost will be taken after 14 days from the system. Okay, and again it will be kept for curing for next 90 days. This is one another model called a Novi Comp design, and here what is the advantage is like one operator can handle the entire compost process. That is the advantage here. But if you are checking with the windrow composting, we need a lot of machineries and manpower. But in this type of in-vessel composting, manpower requirement will be very less. But the cost of initial cost and the operating cost will be somewhat higher compared to open system. So this is again the centralized and decentralized composting system I am going to discuss. The same one open system, we have aerated pile, that is static or aerated pile, and that windrow or agitated pile. But in in-vessel system, it may be horizontal flow or vertical flow, and the air flow direction will be opposite to the feed direction. That is another system, another thing we have to note down. Okay, here you can see the comparison of different composters. That is individual composter, that is for the home we can do, and then community composter for a community we can do, and then big HANA bioreactor for industrial scale reactors we can say. So what are the difference? Like does the bio waste leave the home? But individual composter, it should not leave the home, and other things it should be collected and transported. And the economic cost, if you see, individual composter will have low economic cost, and the others will have medium and high economic cost. So comparatively, this table shows the if you are following individual composting, that is like in your backyard itself, in your home itself, if you are doing composting, then it will reduce the cost of transportation, because there is no need to collect the waste from your home. So the collection and transportation cost will be reduced. As we have discussed in the third week itself, the major cost associated in the solid waste management is 90% of the cost of solid waste management will be incurred in collection and transport itself. So we can reduce that much huge amount if you are following home then like individual composting. Okay, that is the advantage of individual composting. So you can see one of the compost plant in Guwahati, that is in Baragon dump site, and this first they will collect the waste, and the unsegregated waste will be kept in the place, because if there is a house to house, home to door to door collection, if segregated waste is there, then we can easily go to the micro composting plant, only the organic waste. But if it is a mixed waste, then segregation need to be done before keeping in the compost drum. So first we are storing and then drying, because it will have high moisture content, so it should be dried enough. Then after trommeling, it should be going to the compost plant, because unsegregated waste need to be trommeled, and only the organic matter need to be screened out. That should go to the compost plant. So this is the thing they are doing. First, it's like stored unsegregated waste. Then unsegregated waste will be trommeled. This is the thing I am talking about, trommel screen. So this is the round drum kind of thing. This is not the compost drum. This is the trommel screen. So it will have some pores at its surface. So like 30 trommel screen, 6 trommel screen, 4 trommel screen. You can see in the next picture. So 35 trommel screen in the sense 3.5 centimeter holes will be there, circular holes or square holes will be there. Whenever the feed comes in, the material will less than that 3.5 will fall through this. Um, Sorry, it will be coming through this area. Yes, correct. From this area it will come, and then first whatever the 16 will be taken out, and then wait, this is like 35 oh yeah, correct. The feed will be through this area. So first 3.35 things will be less than 35 will fall down, and then the things which are greater than 35 will go on to the other end. Then the whatever passing through the 3.5 will be taken to the 60 trommel, and then the 60 trommel will see the particle which is less than 1.6 centimeter and which is greater than 1.6 centimeter will be taken out, and it will separate whatever the organics present in the solid waste that will go to the compost plant. The segregated organic waste will be dried to reduce the moisture content, and then this will be fed into the uh, compost yard. That is the final compost you can see. After composting, the final compost will be having somewhat poor quality, because we can say this is whatever things we are having will be will not the biological degradation process. This is simple mechanical segregation process. So this type of compost process will give you poor quality organic residue, and this is from the mixed waste, not homogeneous waste. So that's why the quality is poor. If you are doing with the organic compost and biological composting process, then this is called a proper compost having good quality organic residues. Okay, but this type of mechanical segregation is not called compost. Only the organic residue we can say. But this is also where people are using in the agricultural field. If it is a pure organic waste, then we can sell the compost for around 10 to 15 rupees, but this will be spent for around 5 rupees or 2 rupees per bag, like that it will be sent for the agricultural field. And also it may have some contaminant like heavy metals or any type of trace element it may have, because it's coming through the different heterogeneous waste, and it may have some battery waste, some electronic waste, and some of the hazardous waste. So the organic particle may also have the same trace element present in it. So the quality is very poor, and it is not suitable for using in the agricultural fields. And some of the examples are Okla compost plant. 1 second. Yeah. So some of the other examples are Okla compost plant and Agra compost plant. You can see here, and Ambala compost plant. This is Trichy compost plant. You can see one of the thing I have already visited in Trichy itself. We have a 52 micro compost plant. One of the compost plant is shown in the figure, and then Chandigarh compost plant. These are all trommel screens only. You can see the trommel screen, bigger trommel screen. We don't think this is normal screen. In home also we can have some normal trommel screen around 20,000 or 25,000. I bought one trommel screen for my project, and these are all like industrial scale trommel screens around 30 lakhs or 20 lakhs. That kind of trommel screens are there. Okay, I will show you what are the trommel screen I have purchased. I'll show you once. Oh, sorry for the delay. Yeah, this is the Trommel screen I have purchased to save the landfill mined fraction, that is a soil material. So you can see the figure. This is around 35,000 I have purchased. So that is having a size of 4.75 mm sieve size. Yeah, I think you can see the screen. So it will we will send the feed through this, and it will be rotated through a motor, and then or manually also we can rotate through the handle, and whatever the thing less than 4.75 mm, that is what I need. So that will be collected at the bottom, and then the material greater than 4.75 will come out through this. The same thing we can use for compost process also, and many people are using for I can show the video also. So this is the thing I have prepared. So this is the 18 mm soil-like material. I want soil-like material less than 4.75 mm. So you can see some of the videos. It's not loading. Yeah, you can see how it's rotating. Yes. So whatever the things I am getting down, that is less than 4.75, and whatever greater than 4.75 will be segregated separately. This is the function of Trommel screen. Okay. Yeah, I'll show you. So share the video in the problem solving session folder. You can check. Okay. Yeah. So here you can see the decentralized composting process. How the waste is first shredded, the food waste or the organic waste first segregated and shredded. That will be fed into the pilot scale rotary drum of around zero point 0.9 dia and a length of 1 meter with a metal chain at the thing, and then it is made up of metal sheets because it may have some sharp edges from the waste, so it should be handled with a metal sheet, and then it can be manually rotated. We can rotate the drum, and the composting will be happening inside the drum itself. So what are the advantages of rotary drum composting? It should be we can do the composting in a shorter duration, and temperature reaches up to 65 to 75 degree easily, and less space is required. No need of windrow kind of composting, and no other problem, and easy to operate, and yield will be uniform because we are directly rotating the drum itself instead of mixing the waste. So then environment friendly and no leaching or spillage because everything is happening inside the drum. No, nothing will be leached out, and nothing will be spilled out. If you are doing open composting, then through windrow, the equipment will a tractor kind of equipment will mix the waste from this end to that end. That will cause some spillage, and whatever the leachate coming out, that should be collected and treated separately. But in rotary drum, that are all advantages. But the limitation is capital cost is higher, and the power requirement will be higher, but that is comparably negligible only. Okay, this is by pilot scale reactor feeding, and then inside view you can see, and different types of research they have done in IIT Guwahati by Professor Ajay Kalamdad sir through waste management research group, that is WMRG. You can also check in Google and follow. So they did some of the organic waste that is not possible to not possible. It is like a very tedious to degrade, like water hyacinth and hydrilla verticulata and sewage sludge. These are the paper and pulp mill waste you can see that are having high COD. Whenever the BOD and COD ratio we have to find, if the BOD is higher, then it is easy to degrade biologically. The COD is higher, then we have to go for some chemical treatment. But here you can see paper and pulp industry waste are having BOD by COD ratio less than 0.6. So COD will be very higher. So this type of waste which is organic but not readily biodegradable, we have to go with some this type of wind vessel composting because the in vessel composting itself we can directly reach that 70 degree, that is the active phase we can easily reach in 4 to 6 days itself. But in open composting it will go up to 15 days to 40 days to reach the active phase. So in 20 days we can get the matured compost. So this is the advantage of using in vessel composting. So this type of waste also we can use in vessel composting. Water hyacinth you can see everything is reaching 70 degree temperature, and hydrilla verticillata and this type of sea-waste sludge and paper and pulp industry, everything is following the same phase: a growth phase, active decomposition phase, and the maturation phase. And we are getting the result in 20 days itself. Okay. And Pumdi biomass, you can see in Manipur, this is one of the uh, what we call like a plant waste that, and some of the weed, terrestrial weed, we can use this type of universal composting. This is the one of the rotary drum where they are using, and you can see the paddle or the blades that will mix the material inside the drum. Yeah, this is a composting shed, and then feeding, and then waste within the drum. And while turning, you can see some of the water vapors coming out. With this high temperature, 70 to 80 degree, the moisture present in the waste is converted into water vapor, and it is evaporating, and most of the CO2 will get emitted. So these are the final product you can see, initial waste and the final product. And then feeding inside the thing, and then outlet. Curing time will be after taking out from the universal composting, whatever the product we are getting, that should be cured for next 40 days. Then it will be sieved through trommel screen or manual screening. Then the final compost will be ready. Okay, this is the temperature profile. If you are feeding in the inlet, after a growth phase, you can see in the second day itself, we can get 68 to 75 degrees Celsius. And in the third day and fifth day, at the middle zone, you can see 58 to 64 degrees Celsius. And in the seventh day, at the outlet, it will be around again ambient air temperature. That is around yeah, I think admitted. Okay, so in the outlet, you can see the matured phase. Matured phase will be in the temperature of again the ambient air temperature. Yeah, here you can see high rate decomposition. In Universal, once the material is like this, the composting material, before turning, but after turning one round, you can see some of the waste is coming, some of the waste already came out. So you can see some vacant space here. That is called inoculum. You know what is inoculum? Inoculum is the material which is having a rich microorganism that is useful for the further feed to decompose. So we are adding some of the material from this end. Again, feed will be happening. This inoculum will give you more microorganism to degrade the feed that is coming in. Then after another rotation, that is the second turning, it will be turning into a straight line or a stagnant phase. So this, here again higher microbial activity will be happening. Then per day we have to turn 2 times. One is before feeding, another one is after feeding. So this after turning, whatever the material available will act as inoculum for the further feed to decompose. So here higher microbial activity will happen. So this is called high rate decomposition process. This will not happen in the open composting. This will only happen in universal composting. Okay, so how the total organic carbon is reducing? Initially the total organic carbon was very higher, and finally it is reaching around 12. So this is the outlet total organic carbon we can see, and total nitrogen will be increasing because we are going to see the nitrogen components. We are going to see in the upcoming slides what are the different forms of nitrogen, like ammonia nitrogen, and then N2, and then organic nitrogen, how it's TKN, how it's present in the compost, we are going to see. But for the final product, will have high nitrogen content. And then carbon to nitrogen ratio, because carbon is reducing, carbon to nitrogen ratio will also reduce. And then Solvita maturity index. This is the one used to identify the CO2 utilization, sorry, oxygen utilization rate and the CO2 absorption emission rate. So Solvita maturity index will be increasing. After some of the days, like it will become stagnant. Initially, it will emit more CO2, then it will become stagnant. So this is the traditional composting process. Composting period will be around 45 to 190 days. Initially, it will be growth phase, then active stabilization phase. It will reach 70 degree first 7 days, and then next 25 days, and then last 30 to 150 days will be your maturation phase that will have stagnant temperature. Mesophilic, thermophilic, and mesophilic. This is the thing we have discussed in the last week. But the same in the rotary drum, there is no need of growth phase because we are already having inoculum, having higher rich microorganisms. So that directly start the active stabilization. So it will reduce the time for composting. See, 45 to 190 days into 12 to 20 days. Active stabilization will take only 5 days, and then cooling will take 2 to 3 days, and then maturity will be 7 to 15 days. So thermophilic and mesophilic is the first and second phase. So why we are so first decentralization? It will be easy and less time, and the collection and transport cost will be reduced for rotary drum in at site treatment options. This is all at the backyard of the home itself we can do. Okay. Yeah. Then after forming the compost, how to check the quality of the compost, whether it is good or not good to be used as a soil amendment in the agricultural field. How to check the quality of the compost. Yeah, you can see here. A compost should be measurable. Whatever the property we are going to measure, that is different from what are the characteristics we are doing for the agricultural soil. So the compost character will be different and the soil property will be different. So we can't measure the same properties of the soil. It's not applicable for the compost also. So we have different criteria for compost to be good. It should be well matured. That is very important, because if the compost is not matured, it will take the nitrogen from the agricultural soil when it is applied to the agricultural land. That is called a nitrogen robbing. That is what we have discussed in the last lecture. Soil nitrogen robbing will happen if the compost is not matured. So finally, matured compost we have to keep, and then no foreign material like plastics, paper, that should not be there in final compost. And then low amount of trace metal. As I mentioned, trace metals are the heavy metals we can say, which is having the density greater than 5, and then atomic number greater than 20. So these are all the characteristics of the heavy metal. This is very present in very minor quantity like microgram per kg, but this will cause huge health impacts. So that is the problem we are facing with the trace elements. So that should be very low, like copper, chromium. This type of heavy metal should be present in a lower quantity in final compost. It may come through some of the electronic waste if it is mixed with the organic waste, like in the home itself. In the same dustbin we are putting the batteries, we are putting the electronic waste, and the same hazardous waste we are putting in the same dustbin, and the same dustbin we are placing the kitchen waste. When it is segregated, the organic waste may have some trace elements from the hazardous waste. So that will be reflected in the final compost also. So that should not happen when it is applied in the agricultural field. If it is applied, then the plant will absorb this trace metal, and again it will end into the food chain. It will affect the human health. So this is the whole thing we have to broad spectrum we have to think about, and good physical and chemical characteristics. I am going to discuss what are the physical and chemical characteristics in the upcoming slides, and it should contain humic substances. So what is humic substances? We have discussed in the last class. That is the final decomposed organic matter. It may have less degradable organic matter, high amount of lignin and cellulose and heavy cellulose. That is called humic substances, and there should not be any pathogenic organisms. So initially we know compost there is no chance of pathogens, because during the active phase itself it will reach 80 degree or 75 degree and it will kill all the pathogens. So whenever there is a present of minor quantity in the compost, that should not be there. It should be killed, sterilized properly, and no organic matter. Whatever the organic matter, that's all degraded only. So only humic substance should be present. These are all good quality of the good compost. Well matured, no foreign matters, low amount of trace material, good physical and chemical properties, contains human substances, no pathogenic organism, and no organic contaminants. And what are the physical parameters required for a compost? It should have a good bulk density, porosity, void ratio. These three are interrelated. We are going to discuss in the next slide what is how these parameters will affect the soil property and water holding capacity also. And then the chemical properties of the compost, such as pH, electrical conductivity, EC is the electrical conductivity, and TKN is the total Geldal nitrogen, and then ammonia content. These two are the form of nitrogen only. Ammonia is also nitrogen. Total Geldal nitrogen is also the form of nitrogen only, and then total and available phosphorus. These are all what are the important nutrients required for plant growth: N, P, and K, nitrogen, phosphorus, and potash. So this three should be in optimum level in any compost to be used as a soil amendment. And then macronutrients such as sodium, calcium, magnesium, iron should be present in minor quantity. Okay, that's also required for a good compost. And then biological parameters such as soil BOD and soil COD. You know what is BOD and COD for water? Biological oxygen demand, biochemical oxygen demand, and chemical oxygen demand. These are the two important parameters to denote the presence of organic matter, amount of organic matter present in the water and wastewater. The same thing we are discussing for soil BOD and soil COD. And then coliforms. It's not caliform, it's coliform, CO. Coliforms are the one which are coliforms are the microorganism which is able to form colonies. That is called colony forms or coliforms, we can say. So total coliforms and the fecal coliforms we need to check. Okay, how much the coliforms are the one which is coming from human feces only. So this E. coli and this type of microorganism should not be there in compost. And then stability. How to check the stability of the compost? By oxygen uptake rate and the CO2 evolution rate. If the CO2 is not evolving, then the compost is stable. No degradation is happening. No further degradation is happening. So the compost is matured. And then oxygen uptake rate. When the oxygen is not taken for degradation, and it is fully completely degraded. That is the two things we are checking for the stability of the compost: oxygen uptake rate and CO2 evaluation rate. So these are the parameter, physical, chemical, and biological parameter we need to analyze for the compost final product. Okay. So in physical property, we have discussed about the porosity, void ratio, and bulk density. These three are interrelated, as I mentioned. Compost are the lighter particle, we know, and finer than soil particles. Soil are very bulky particles. You know, na? What is the soil in the agricultural land? That is very bulky. So if you are mixing the compost under the soil, then the soil will decrease its bulk density, and more finer particle, it will increase more absorption area. Then the moisture available in the soil will also be more, because there is more area to absorb. So moisture will be absorbing to the compost particle, and which in turn increases the water holding capacity, which is also increasing the void ratio and porosity. If the pores are more, porosity will be higher. If the path for water flow will be higher, then the void ratio will be higher. So these all are interrelated. Whenever the particle become finer and the bulk density will be lighter, and then the absorption area will be higher, this will increase the water holding capacity, void ratio, and the porosity. So this is the thing we are discussing. So normal soil will have high bulk density, high weight, and less pore. If you are mixing the compost, it will reduce the bulk density, it will reduce the weight, and more pore space will be available. That is more porosity, more void ratio, and more water holding capacity. So if more water is holding in the soil, then the plant can easily take the water from the soil, and the plant growth will be higher. That is the ultimate aim. Okay. Then in the chemical properties, first is the pH. As we all know, pH will reduce initially during the growth phase, and it will start increasing during the active phase, and then the final compost will be highly neutral. That is the thing we have to check. If the pH of the compost is around 7, then it is a proper compost. If it is in 6, then it is started degrading, and if in alkaline phase, that is 8, then it is in ammonia releasing is happening. That's why the pH is increasing. Ammonia releasing. First, why it's decreasing? Organic acids are producing, like volatile, whatever the organic matter that is converted to sugar, then the sugar will be converted to acetic acid. That is a volatile organic acid. Then this organic volatile acid will be converted to ammonia. So this is the phase of degradation. So initially acid will be produced, so the pH is reducing. Then the ammonia will be liberated, so pH is increasing. Then ammonia volatilization is happening. And final matured compost will be having highly neutral pH, that is around 7. The pH of the final compost will be 7. Okay, so this is the thing. At a higher pH, what will happen? The essential nutrient will precipitate. What are the essential nutrients like nitrogen, potassium, phosphorus, and all these macronutrients like calcium, whatever we have discussed, like sodium, calcium, and magnesium, iron. This all will precipitate. So we should not go up to higher pH. It should be around the optimal condition of 5.5 to 8. This is the thing we need to maintain for compost microorganism. Yeah, another one is like nutrient availability is important. Another one is microorganism growth. Microorganism will grow in this optimum pH level only, 5.5 to 8 only. Okay, this is another kind. and then generally the pH of the compost will be around 6 to 8, and if we have to modify the compost pH level to counterbalance and amend your agricultural soil. If the agricultural soil is more acidic, then we can use this alkaline compost. If the soil is more alkaline, then also we can use the compost to counterbalance the pH of the agricultural soil. Okay, then vegetation and plant requirement is 6 to 8, but microorganism will grow in 5.5 to 8. These are all things we have to note down. Final compost will have neutral pH, that is around 7 or 6 to 8, we can note down. I hope you understand. This is another nutrient availability chart at a different pH. So what I have mentioned, the compost should be from 6 to 8. You can see this range will have all the nutrients available at a higher quantity. If you go in acidic side, most of the nutrients are not available. In alkaline side also, most of the nutrients are not available. But in highly neutral, that is 6 to 8, all the nutrients are available. So this is the availability chart of nutrient at a different pH, and the final compost will be having neutral pH with all these nutrients. So the stoichiometry for composting was proposed by Techno Banagla's book, also you can refer. So this is the stoichiometric equation to calculate how much CO2 will be oxygen is required for the composting process, how much CO2 will be liberated and how much water vapor will be liberated. This kind of thing we can check through this stoichiometric equation. How much oxygen requirement will be calculated from that. Then the second chemical parameter is the electrical conductivity. As you know, electrical conductivity is directly proportional to how much soluble salt or mineral salt present in my compost sample. So whenever there is soluble minerals are present, my electrical conductivity will be more. You know, water will have no conductivity because water won't conduct electricity. Whenever there is a ion present in the water, then it is more conductive. Okay, so pure water is H2O is not conductive. Whenever there is a element, a salt present in the water, then it is highly conductive. So like soil also, if you dissolve in water, whatever the mineral salt present in the soil will leach into the water, it will become more soluble. So my compost should have good solubility, good electrical conductivity. Then only the mineral salt will mix with the water in the agricultural land, and the plant can take this mineral. So that's the ultimate aim. So concentration of final EC also depends on the conductivity of the soil. So it will be required 2 to 3 decisimon per meter. That is the conductivity unit. Decisimon is the unit, simon per centimeter or simon per meter. Here the unit is decisimon per meter, 2 to 3 decisimon per meter. That is the unit of conductivity. Okay. So initial growth phase, the conductivity will be very less because there is no degradation happened. But during active decomposition stabilization process, most of the ions will be released. That's why the electrical conductivity is higher. After precipitation of the ions at a higher pH, so here we have checked the higher pH will be happening at active stabilization phase, and higher pH this element will be minerals will be precipitated. So again it will reduce the electrical conductivity. Final final thing is like a final requirement is 2 to 3 decisimon per meter. If it is higher than this content, electrical conductivity, it will cause phytotoxicity. What is phytotoxicity? Toxicity is the term used for like whatever the toxic things that can happen to the human beings, or the element which is causing toxic effects to the organism. Phyto in the sense plants. So whatever causing toxicity to the plant, that are called phytotoxicity. Whenever the EC is greater than 2 to 3 decisimon per meter, then it will cause phytotoxicity to the plants. Okay. Then organic matter, as we know, initially it will be higher. Then during degradation process, organic content will be reduced, and at the final compost, only small quantity of organic amount will be present. What is that? That is the lignin and cellulose and hemicellulose that is present at the final compost. So what initially microbial assimilation period and easily biodegradable organic matter like protein, fat, carbohydrate will be degraded, and then hard to degrade lignin content will straight to degrade, and in the final compost newly formed macromolecule and humic substance will be present. That is called stable organic fractions. That is also organic, but that cannot be degraded by microorganism. That is called stable organic fractions. Okay, at time of composting, the organic compound will reduce. So how the pH is changing, how the EC is changing, how the organic matter is changing, and the nutrient, if you see, these are the, sorry, nitrogen dynamics, we can say. So what are the four forms of nitrogen I told? Total nitrogen, that is the combination of organic nitrogen, nitrate nitrogen, and then ammonia nitrogen. NO3 is nitrate nitrogen, and ammonia nitrogen. Initially, the total nitrogen will be lower, and then because of ammonia production, the total nitrogen will increase. That's why the ammonia nitrogen, you can see here, the ammonia nitrogen is increasing. Then finally, the whatever the produced ammonia will reduce. That is called loss of ammonia, and again it will reduce. But nitrate will produce from the ammonia will be oxidized to NO3. Whatever the organic nitrogen present, that will be converted to ammonia. Then the ammonia will be oxidized to nitrate. But finally, the total nitrogen will increase. That is because of nitrogen fixing bacteria that will fix the atmospheric nitrogen to the soil compost. Okay, so ammonification will happen, loss of ammonia will happen, then nitrification. Nitrification is conversion of ammonia to nitrate. That is nitrification will happen. Okay, so this all three add up will give you the total nitrogen. Then, as I mentioned, stability can be calculated based on CO2 evolution and oxygen uptake rate. When the CO2 is not evolved, then it reaches the maturity phase. Initially, during active decomposition phase, what will happen? More CO2 will be liberated, more oxygen will be utilized. But during maturation phase, no oxygen will be taken and no CO2 will be liberated. That is, decline in the organic carbon and release of CO2 will happen after reaching the maturity phase. Why it's taking the carbon? Because microorganism need carbon as a source of energy and nitrogen as a nitrogen for its body growth. So for metabolism, it's required to take carbon and nitrogen in the ratio of 1:3. 30:1. So oxygen utilization rate will also reduce. When the oxygen consumption is higher, then the microbial population will also be higher. Okay. Then the trace metal I have mentioned. Whenever the trace metal like heavy metals are present in the soil, it will reduce the soil fertility. No plants will grow. Any heavy metal, if it is present in the soil, then the soil fertility will be reduced and it will alter the microbial population and it will modify the carbon mineralization and anomalous nitrogen transformation will happen. So these are all the direct problems related to soil health. And indirect problems like crop will get contaminated under water pollution. How the water pollution will happen? Whenever the rain happens, it will leach the trace element or heavy metal present in the soil to the nearby water bodies. So the runoff will reach the river or nearby well and it will create water pollution and also the air pollution. So induced oxidative damage and modification of signaling and the biosynthetic pathways. You know what? These are all related to plant health. This is related to soil health. And then abnormal reproductivity response and anomalous genetic behavior of the plants. So the trace element and the heavy element should be reduced because it's directly affecting the soil health and indirectly affecting the plant health. As I mentioned, whenever there is a heavy metal present in the soil, whenever in a solution form, it will be absorbed to the plant root and it will be transferred to the leaves and the fruits. So again, it will affect the human health and food chain. Okay. Then pathogens. So what are the coliforms we have discussed? Fecal coliform and the total coliforms. So fecal coliform fecal coliform will be from humans and the fecal streptococci from animal feces. So this two should be in the range like 5 into 10 power 2, that is 500, and 5 into 10 power 3, 5000. So fecal coliform should be 500 mpn per gram of compost, and in streptococci it should be 5000 mpn per gram of compost. So the presence of coliform is the indirect indicator of overall sanitary quality. So whenever the compost is in good sanitary quality, then the coliforms will be lesser. Salmonella species are regarded as a problem for hygienic quality. So this should not be present in compost. Okay, these are the limit given for coliforms in compost. So we have discussed about physical property, chemical property, and biological property of the compost, and then how it's creating the phytotoxicity. As I mentioned, whenever there is a trace element present, so it will it is a suitable. It is a method suitable to evaluate how the compost is suitable for agricultural purpose or not, and it will should avoid the environmental risk before this compost can be recycled back to the agricultural land. So we have to test the phytotoxicity. How to test the phytotoxicity? By seed germination test, we can say. So we have to take some seeds like onion and some of the I have done on seed germination test. This report I will post it in the problem solving session folder, or I will explain at the end. So how the seed germination test was done. So I have taken one waste sample. The same like you can take the compost sample. Phytotoxicity, as I mentioned, toxicity is the one which will affect the growth and health. Phyto means plant. So phytotoxicity is the one which will affect the plant health and plant growth. Hope you understand phytotoxicity. So I am applying this compost to the agricultural land. So it should not affect the plant growth because it will enhance the soil property like void ratio, porosity, water holding capacity, bulk density and all, it's increasing. But how the plant growth it will increase or not, that's what I am going to check by phytotoxicity test. That is called a seed germination test, we will say. So I am putting some of the seeds like white barley or sesame seeds or any kind of things you can add to the compost, and the normal agricultural soil as control you can take. After that 25% of compost you can add, 50%, 75, like that different composition you can add and check for plant growth. You can see here in one type of compost extract, this is extract test, this is direct compost test. In the direct compost you can check the seed growth, or in the you can pour some water from the in the compost and you can take the leachate, that is extract, and you can try for onion growth. In this type you can see 25% will give the good growth and then 50% also given good growth than compared to control, that is normal agricultural soil. So I can use this compost as 50% replacement for normal agricultural soil. If I go beyond like 70% and 100% replacement, again the plant growth got reduced. So this is like a direct visual method, we can easily calculate the phytotoxicity. So here you can see in the compost controlled agricultural soil, the plant growth and root growth was good. But if I am applying more compost, then the plant growth got reduced. Hope you understand this phytotoxicity test. Got it, sir? Okay.
Yes, sir.
Yeah, okay. I'll move on. We have so compost should have a good quality, like good physical, chemical, and biological qualities. Then the phytotoxicity should be assessed before applying to the soil. Then what if the solution, if the compost made is not good quality? So whenever there is a heavy metal is present in the compost, so I know there is a heavy metal and there is some trace element present in the compost. What can I do? So I can add some admixtures or chemical fertilizers before adding to the agricultural soil, like some chelating agents. I can say chelating agents are the one which will precipitate the trace elements or heavy metal present in the soil, the compost. So some of the chelating agents like lime or zeolite or biochar can be added. So that will keep the trace element in a precipitated condition. So whenever there is a rain happen or runoff happen, this element won't flush it off, and this cannot be taken by the plant. So this is the admixture or chelating agent that should be used whenever the compost is in not good health, good quality. So we can add this admixture or external agents like lime, zeolite, and biochar that will hold the trace element. It won't precipitate. It will be precipitated. It won't leach, and it will not be absorbed by the plants. You can see this example. Control, that is the normal compost will give less growth, and if you are adding compost and biochar, that trapped the heavy metal and the plant growth, that is the lettuce they have tried. So lettuce growth was higher. Okay, this is the thing. And we have different regulation. Last class also I have explained about the FCO standards, and I have posted the same standard in the folder also. So different countries have different classifications. Like major will be type 1, type 2, type 3, or class A, class B, class C, based on the compost quality. So I have to assess all the parameters like physical, chemical, and biological. If it is matching with the first class, then that is first class compost or class A compost. Like that I can differentiate the compost based on the guidelines. So different countries have different guidelines, you can see. And compost quality seals also available. You know what is seal? So Austria having different compost seal, quality seal. So that are all like we can say trademark, we can say. So this type of seal should be there if it passes the compost quality. Like USA also having separate seal based on their regulation. Okay. So German, they are having some separate standard for heavy metal, and the US and UK having separate permissible limits for metals. And you can see for typical soil also they have some recommended metal levels. But in India we have separate standard. You can see this is nutrient standard like NPK, calcium, and phosphorus standard based on German, Austria, and USA. That are the standards. So maturity test I have mentioned about DWAR, pass plant test, and Solvita test. So these are the tests like we can do. That is Solvita test we can use for CO2 uptake rate, CO2 evolution rate, and oxygen uptake rate. So these are all the tests available for checking the maturity. So in USA they are using Solvita test. Okay. So salt concentration also they have given. That is salt concentration is directly proportional to electrical conductivity is directly proportional to the salt concentration. So if the salt concentration is lesser, electrical conductivity will be lower. Okay. Different standards are also there. And then as I mentioned, the phytotoxicity test, that is the plant growth test. Germany is having separate guidelines, Swiss having guidelines, Australia having guidelines. So that is mentioned 25 and 50% compost in the standard soil media. Barley and cress seed should pass greater than 90%. So 90%, if I plant 100 seeds, then 90 seeds should grow well. Only the 10% cannot grow, may not grow well. So this is the guideline that the compost should pass. Okay. Then US EPA, that is the United States guidelines for using the compost as a soil amendment. What are the pH, soluble salt concentration, moisture content, organic matter, particle size also it's mentioned. It should be 98% of the compost should pass through 3 by 4 inch screen. That is, we can say like 2 centimeter screen. It should pass 20 mm. And then the biological contaminants also they have some criteria. It should meet. It should not exceed US EPA Class A standard. Okay. And then Canadian Council also having separate compost standards. It mentioned the category A, category B, that is unrestricted and restricted compost. Unrestricted compost can be used in the agricultural, residential gardens, horticultural field. Restricted compost should not be used for any food production. And then stability test, as I mentioned, the CO2 evolution and the oxygen uptake rate should be within the standard. This is what's mentioned in Brinton paper. You can refer. That is and germination test. So that should pass greater than 90% if it is a very good matured compost. If it is less than 80, then it is called immature compost. This is what the Indian standards. So these are all the global standards, and now we are coming to the Indian standard. We have a separate guidelines given by CPCB for the compost. That is a final product. What are the heavy metal can be present within the limit. So we have a stringent standard like 10 milligram per kg of dry basis of the compost. So if you take 1 kg of compost, arsenic should be less than 10 milligram. Mercury should be less than 0.15 milligram. So you can see the stringent level we are following for the heavy metals. And then for FCO standard for different physical and chemical property. As I mentioned, total nitrogen should be minimum 0.5. These are the required nutrients. Nitrogen, phosphorus, and potassium should be minimum 0.5 and 1. So it can be greater than that. Other things should be less than these things. Like the element should be less than this value. And then CBN ratio should be maximum 20. It should not be greater. Okay, final compost should have 20. But initial feed should have 30. I hope you can understand. And then FCO standard for vermicompost. We are going to see about vermicomposting in the upcoming slides. You can see the difference is N should be 1 because vermicomposting will give you good quality compost, like nitrogen will be more in that, and phosphorus and potassium will be also more, not 0.5, it will be around 0.8 and 1. So these are the vermicompost standards we are going to see in the upcoming slides also. So composting, if you are applying in the soil, it will enhance the soil property and it will protect the watershed. And composting, it will create job. How incineration requires only 1 manpower if you take. Landfill will take double that manpower required for incineration, but composting will give you a more work, like what we say, like work opportunities. It will create job. So job opportunity will be more in composting if you follow. So we can also do a community level composting. We can also engage women for composting. This type of job opportunity we can explore for community level composting. So these are all indirect advantages of composting. When a compost, how can we say in a layman point of view a compost is good or not without doing all this test? How can we say a compost is good or bad? If there is any foul smell is coming, then it is having some ammonia or a toxic compound, so it is a bad compost. If you squeeze the compost, then there is a water coming out draining the water, then it is not a good compost. What we have mentioned, the compost should be very dry and that should spread in your hand. If you take, that is a good compost. So good compost will be having proper texture and color, no foul smell, and appropriate moisture content, and it's not big sticky or greasy, and the color should be dark brown. Waste will have green color and the compost will have dark brown color or any black color. So it should be free from insect and nematodes. These are all, as a layman point of view, we can check the compost quality is good or bad. Then coming to the vermicomposting, that is one type of composting only. That is not a different one. That is a type of composting. We are using the earthworms to do this composting process. Instead of microorganism, we are using the earthworms, because earthworms in its gut, it's having some of the microorganism that will degrade the organic matter in the solid waste, and whatever the excreta from the worms, that we are using as a vermicompost. So this is the whole process of vermicomposting. So what are the different worms we can use? Red wigglers, that is Eisena fetida, and white worms, that is Enchitra buzzlozi, and other earthworms. These are the red wigglers, and this is the white worms we can say, and other earthworms are used for vermicomposting process. What is vermicast? Vermicast are the worm casting or the worm humus. Humus is the one which is the product, final product. Worm manure or the worm feces we can say. So this is the final end product, which is the breakdown of organic matter by the earthworms. So this is a good nutrient we can say. It's rich in organic fertilizer and we can use as a soil conditioner. You can see the cost of vermicompost will be higher compared to normal compost. Normal compost, as I said, 10 to 15 rupees per kg, but this type of vermicompost will be around 40 to 50 rupees per kg. So you can create some job and you can earn some money by doing vermicomposting. Many agricultural people are doing vermicomposting in their backyard and they are earning some money out of vermicomposting process. So you can see here cow pat pit. So whatever the cow dung, they are putting in this pit and they are adding worms and doing the composting process. This is vermi wash. Vermi wash is the leachate collected from the vermicompost, whatever the water coming out and whatever the product coming out, both are called vermi wash only. Okay, then this is one type of vermicompost pit we can say, made up compost we can say. So here also biodegradable material, we have to mix first homogeneous, because worms will act only on the homogeneous material, because whenever there is heterogeneous material, all the worms will die. So we need a homogeneous mixture, and then worm we need to give what is the earthworms, and then oxygen we need to supply. Proper moisture should be maintained. If the moisture is higher, then worms will die. It will create an anaerobic condition. So oxygen and water should be maintained properly. What are the product? Ammonia will be liberated, CO2 will be liberated. Finally, earthworms will be harvested, and then vermicompost with the living culture soil microbes will be taken. So earthworm harvesting is, we have to take out the earthworms for next cycle, and then the final vermicompost can be taken out. So this is the mechanism of vermicomposting. So what are the three worms used in the vermicomposting? First one is anasic. Anasic is the one which will be acting on the deep soils. So whenever there is a big pit, so then the deep soil will be acted upon by anasic earthworms. But endogic is the one which this anasic is used for fishing purpose also. You can see in the bait we will keep some microbes, earthworms, that is this anasic earthworms. Then endogic is the one which will be always living on the upper layer of the soil. It will build burrows on the upper layer of the soil. So there it will create compost. And epigic is the one that will feed on the decaying organic matters. So this is the epigic microorganism. So this is good, useful for vermicomposting. It should not form burrows. So other two will form burrows, but this won't form burrows, and it will be acted upon on the decaying organic matters. So you can compare the life cycle and the different characteristics of these three terms. One is anacetic and endogic and the epigic. Finally, we can say anacetic is good for this type of vermicomposting. And what are the different substrate we can give for different worms? So if you are if you know your waste, if it is a kitchen waste, or you are having cow dung, or you are having some sea waste sludge, or any agricultural residue like wheat straw or leaf litters, then you can go to the agricultural office and you can ask for different types of earthworms. They can provide earthworms in a number basis, like 50 worms for 100 rupees, like that they will give. Then you can culture the earthworms. So it will replicate double in 45 days. So if you are having 100 microbes, after 45 days it will become 200. So the reproductive rate of this earthworms will be, worms will be very higher. So you can buy first and you can culture the earthworms with your substrate. So based on the substrate you can do the vermicomposting with the respective earthworms. So what are the silent requirement? It should have a suitable bedding. Bedding in the sense the substrate, how to keep the substrate, and then food source, and then adequate moisture, adequate aeration, suitable temperature, and suitable pH. These are the things we are going to see. Okay, first, what is the bedding? Bedding is the one which should give you a stable habitat for the earthworm. Without a bed, it won't survive. So we need a proper bed. So the bed should have a high absorbency, good bulking potential, and low nitrogen content. If high nitrogen is there, ammonia will be liberated, and it will be rapid. It will create rapid degradation, because high nitrogen means high carbon also will be taken. What will happen? Earthworms will survive only at a maximum of 40 degrees Celsius. But if high degradation is happening, then active decomposition phase will go up to 70 degree or 80 degree. All the earthworms will die. So it will create fatal environment to the worms. So we should not give higher nitrogen content. We should maintain low nitrogen content. Then only low degradation will happen. But the degradation rate will be very low for vermicomposting. It will take around 120 days or 60 days. And the absorbance will be higher and the good bulking potential will be there for the bed. So which bed is suitable? How can we make the bed? With horse manure, with peat, with paper, with newspaper, with cardboard, like that. Different bedding material we can choose based on different properties. But if available, shredded paper and cardboard makes excellent bedding, because particularly when combined with the typical on-farm organic resources such as straw and hay, it will create a good bedding material. Will have good absorbency, good bulking potential, and low nitrogen content. That is the one we can use, because paper and cardboard will have higher carbon content, low nitrogen content. How to use the food source? We know what is the food source. Organic matter from the solid waste is the food source, like food, kitchen waste. Ideal is like consuming amount of food is higher than the we know the earthworms will feed the food. It will have the food more than its body weight. If it is around 2-3 grams, then it will eat around 6 grams also. So optimum consumption is around half of their body weight per day. So one day itself it will eat around half of its body weight. Then the rate of degradation will be higher. That's the thing. In adverse condition, earthworms can extract sufficient nutrition from the soil also to survive in colder region and all. Third important parameter is the moisture. Adequate moisture should be present, like 60 to 70%. It should not be dry. It should not be more wet. If it is too wet, it will create anaerobic condition and it will create a fatal environment to the earthworms. So the fifth one is aeration. Aeration should be higher, because all the organism requires oxygen and water to live. So excessive aeration is required, and worms will suffer severe mortality because of deprived of oxygen. And less oxygen and more toxic elements are present, then it is severe. There will be severe mortality rate. Mortality is death. Okay. Then temperature. As I mentioned, worm will live only in the optimum temperature range of 16 to 25 degrees Celsius, and temperature affects the activity, metabolism, growth, respiration, and reproduction of the earthworms. So whenever the temperature goes above 40 degree, it will kill the earthworms. So we have to maintain less nitrogen level. Then the degradation rate will be lower. Then the temperature won't reach 80 degree. So that's the thing. Okay. Then pH range for microorganism, what we have discussed, 5.5 to 8, but earthworms required 5 to 9, but the range will be from 7.8 is considered as to be optimum. The pH, if it is lower, drop over time due to fragmentation of the organic matter, it will create acid and it will be reducing. Okay. Other important parameter, pre-composting of organic matter is required, because whenever the composting process happen, it will reach 80°. So vermicomposting will be suitable for second stage of composting. First we can do some windrow composting or in-vessel composting. Then the matured compost or during curing phase, we can use this vermicompost. This is the good thing we can follow. First stage will be from any open or in-vessel composting. Then the second stage can be used for vermicomposting. That will reduce the temperature and it will reduce the mortality of the worm. The salt content is important, because worms are very sensitive to salt. It should be preferred to maintain less than 0.5%. And the urine content, it will create ammonia, and worms are toxic. The ammonias are toxic to worms. And the other toxic element, as I have mentioned, trace element and heavy metals. And deworming medicines should not be present. Like some hazardous material will mortality of this earthworms. How to build this worm home? So this we can use this type of stacked trays. First will be the bedding material. Second will be the waste mixed with the earthworms. What is the organic waste, kitchen waste mixed with the earthworms? Then top of that we can use gunny bags to retain the moisture. So this type of stacked trays we can use. So worm needs air to survive. So several smaller trays can be useful. Other than one large tray, we can keep 3 trays, and you can easily take the center tray and we can replace the waste. So this is the principle behind stacking of trays. Okay, don't use bin that is used previously for chemical storage. That will kill all your earthworms. So the bin should be clean, and it should not have any chemical contaminants. Okay, that should be very shallow, wider and taller. Like optimum will be like 30 centimeter, 40 centimeter, 60 centimeter long trays you can use. So another types of vermicomposting are, we can also do vermicomposting in the form of windrows or wedges or beds, and also through continuous flow reactor. Like a closed reactor also we can do this type of vermicomposting. Different models like England, Korea you can see, and then continuous flow reactors. As I mentioned, inside the reactor also we can do this type of vermicomposting. If it is the scale of production is higher, then we can go for windrow. Windrow is always suitable for community level composting. If it is like a rural area, then we can go for in-vessel composting, like smaller scale production. If it is a medium scale, we can go with the continuous. If it is a small scale, we can go with the reactors, like tray at stacking, batching, or wedge type we can go. Okay. So these are all different examples of vermicomposting and success stories. You can see here is one of the box and the batch type vermicomposting. You can see how the materials, bed material, waste material. Then instead of gunny bags, they have used this tray, rice trays they have used, and then tray and stacking vermicomposting. And how where the location bin should be located, maybe at the kitchen or the basement at the backyard. That should allow proper air to circulate. That is very important. Aeration should be very important. Okay, and then feeding worms, the C/N ratio should be 30:1, same like composting. And whenever you need control acidity, you can add eggshells. Eggshells will provide valuable nutrient, and also it will regulate the acidity of the compost. And then whenever you are adding citrus peels and coffee grounds and tomatoes, it will reduce the pH of the pH of the waste, and it will create acidity to the bedding media. So proper blending and what we can say, shopping of the food waste is required before keeping it into the vermicompost bed. Okay, then how to harvest the worms? We can use this type of light separation method. The compost can be spread in a floor, and whenever the light is added, the worms will come out. That can be easily segregated. Or we can use this type of worm harvester. So this lighter particles like compost will come out. The bigger worms will be stayed, and it can be collected separately. So this is called a worm harvesters. So advantage is like cost will be minimum for vermicomposting. Decentralized thing we can use in our home itself. Many people are doing this type of vermicompostings in home itself, and it is rapid, very useful for peri-urban areas. And worm casting improve the plant growth. As I mentioned, vermicomposting will give, the compost will give good high nitrogen ratio and nitrogen NPK values. So the cost is also very higher for vermicompost. You can earn money and earthworm double their population every 4 months. That's what I have mentioned. 4 months in the sense 4 3 12 120 days it will be doubled. And the disadvantages is initial cost is higher and the survival care we need to take care because it's very sensitive to ammonia, very sensitive to trace material. So the care should be taken for its survival. And some of the problem if you face, how to troubleshoot. If the bin have more food than bedding, then don't add food for next 2 weeks. Then it will be stable. Then if the bed material is too wet or compacted, then please do a stirring or a mixing and stop adding food for next week. Then it will be taken care. Okay, and the bedding material is, if it is too acidic, then you can add eggshells. As I mentioned, you have to stop adding this type of coffee beans or citrus materials and tomatoes. You have to add eggshells that will regulate the acidity and pH of the bedding material. So this is all about vermicomposting. So in this lecture we have discussed about last lecture we have discussed about composting, factors affecting composting, and what is open windrow types. In this, we have discussed about the closed reactor type, that is universal, horizontal flow, vertical flow, xylose, and batch reactor. Also, the compost property, the final compost, what are the properties need to be there to be used as a agricultural amendment, a soil amendment, and then vermicomposting we have discussed in detail. So, if you have any doubt, please post it in the chat box, or you can unmute and you can ask, or else I can move on to the problem solving session. Hope you have no doubts. If you have any doubt in between, please post it in the chat box. I'll move on to the problem solving session. Kindly post the answers in the chat box. Okay. I'll move on to the first question. That is, this is a multiple choice question. Finer the compost particle, the more is the, which will be more. If the compost particle is finer, if it is added to the soil, what it will increase? Void ratio, porosity, absorption area, none of the above. It's a multiple choice question. More than one answer may be correct. So you can see this box. If the box is there, that is a multiple choice question. If it's a circle, then it's a single option. Is correct. So A is correct. Then B, C. You can see the answers are like A, B, C. Whenever the compost is finer, it will increase the absorption area that I have mentioned. So it will hold a lot of water. The void ratio will be higher. Porosity will be higher. So it will increase the water holding capacity, void ratio, and porosity. So the answer is A, B, and C. Okay. So moving on to the second question. So can I give more time to answer? Okay, I'll wait for some more time. What is the optimal pH range for microorganism in the compost? For the microorganism to grow. 5.5 to 8.5, 6 to 7.5, 5.5 to 8, 5 to 8. Option C, 5.5 to 8. Any other options? A. Okay, we'll check with this. What is the question? Can please refer the question again? Optimal pH range for microorganism in the compost. That is 5.5 to 8 only. So you can see here, a 5.5 to 8 is the optimal pH range for the compost microorganism. But the compost will be 6 to 8 for the requirement of plant growth. So what I have mentioned is nearly neutral or highly neutral. That is 7. So the answer is C. For the last question is 5.5 to 8. Answer C is correct. Okay, third question. What is the required optimum electrical conductivity in the compost? That is the easy value, electrical conductivity. 2 to 3 decisimon per meter. The unit is simon per centimeter. You can also take decisimon per meter. That is a conductivity unit. 2 to 3, 1 to 2, 3 to 4, and 4 to 5. The answer is optimum electrical conductivity. Option A. Yes, 2 to 3. That's what the required final EC. So if it is higher than this value, then it will create phytotoxicity to the plant. So it should be 2 to 3 decisiemens per meter. Okay. Okay. So then fourth question. This is again a multiple choice question. Please look into it. What are the chemical parameters analyzed during composting process? Chemical parameters: water holding capacity, soil BOD, ammonia content, available phosphorus. Can be more than one option. Are correct. A, C, D. Water holding capacity. Water holding capacity, a physical property or a chemical property? C and D. Ammonia content, available phosphorus. Okay. What about B? B is biological property. Yeah, correct. So chemical property is pH, EC, TKN, ammonia content, available phosphorus, and macronutrients. SBOD is biological property, and the water holding capacity is the physical property. Okay. Please look into it. So option is C and D. That is correct. So moving on to fifth question. This is again a multiple choice question. What are the properties of a good compost? What are the properties of a good compost? Sticky, free from insects and nematodes, high moisture content, no foul smell. Sir, high moisture content should not be there. Then if you are pressing the compost, it will be draining the water. It should not be. It should be having some optimum moisture content. It will be like dry condition only. It should not have high moisture content. So option B and D are correct. Free from insects and no foul smell. So no foul smell, and bad compost will have high moisture content. Okay. Sixth question. Which of the worms in the vermicomposting build burrows in the deep soil? So some build burrow in the deep soil, some build burrow in the top layer, some will not build burrow. It is good for vermicomposting. So what are the options? Like with this, the question is which forms burrow in the deep soil? Endogic, anasic, epigic, none of this. So answer B, anasic. That is correct. Yeah. So anasic is the one which build burrows, permanent burrow in the deep soil. Endogic is the one which build burrow on the upper layer of the soil. Epigic is the worm which feed on the decaying organic matter, will not form burrows. That is good for vermicomposting. Epigic. So the answer is anasic. Okay. So seventh question. What is the moisture requirement for vermicomposting process? 50 to 55, 75 to 80, 60 to 70, 40 to 50. 60 to 70. Yeah. If less moisture content is there, it is dry. All the microorganisms will die in the composting process. All the worms will die in the vermicomposting process. So if it is too wet, then it will create anaerobic condition. It will liberate ammonia. So again, microbes will die, and this worms also will die. So optimum moisture content of 60 to 70 should be followed. So that is the required moisture in the range of 60 to 70. That is the adequate moisture is required. If it is more than too wet, then it will create anaerobic condition, may create fatal to the earthworms. The same will happen in the microorganism also. Aerobic microorganism will go off. Anaerobic microorganism will form in the compost heap. Then it will create CH4 instead of CO2. Okay. What is the fatal temperature for worms in vermicomposting? If the temperature exceeds dash degree Celsius, the worms will die. 35 degree, 40 degree, more than 40 degree, 16 to 25 degree. Yeah. So that's why vermicomposting cannot be suitable. It's not suitable for rapid degradation process. Normal composting process will, in the active phase, it will create 70 to 80 degrees Celsius. So all the worms will die. So in the second stage, after normal composting, for maturation or for curing, we can use this type of worms. So vermicomposting is suitable for second stage composting. So that will create only around 40 degrees Celsius. So after more than 40 degrees Celsius, this worms will die. The answer is C. So temperature above 40 degree can kill the worms. Okay. So ninth question. on which parameter of composting Solvita maturity index depends. Solvita maturity index. Biochemical oxygen demand, chemical oxygen demand, BOD, COD, volatile content, carbon dioxide evolution. Solvita maturity index is a test which is used to analyze, yeah, carbon dioxide evolution. That is correct. So two things are required to find the stability of the compost. One is carbon dioxide evolution, another one is oxygen uptake rate, OUR. So this two should be stable. No carbon dioxide should be evolved, no oxygen should be uptake. Then only it's called a stable matured compost. Solvita maturity index is used to analyze the carbon dioxide evolution. So that is a test. Okay. So this is how the Solvita maturity index, that is a carbon dioxide evolution. It will be more and it will reach a saturation phase. Okay. So the property of good bedding material is bedding material in the vermicomposting. High absorbency, good. It's a good bulking potential, low nitrogen content. All of this. Bedding material for vermicomposting. Yeah, all of this is correct. So bedding material should have high absorbency, good bulking potential, and low nitrogen. Why no nitrogen? Nitrogen is higher, then all the carbon will be taken because 30 carbon will require 1 nitrogen. If there are 2 nitrogen, then 60 carbon will be taken. So there will be rapid degradation. So heat will be evolved. So it will reach around 70 degree. All the forms will die. So low nitrogen content, good bulking potential for the movement of worms, and then high absorbency are required. Then only the oxygen supply will also be proper. Aeration will happen. Okay. Again, what are the reactor configuration in vessel system? Reactor configuration: horizontal drum, open tank, and vertical xylose. All of this. Reactor configuration for in-vessel composting system. So it may be a horizontal drum, or it may be a vertical xylose, or it may be a open tank. That is a batch reactor. So all of these are correct. Here you can see horizontal drum, vertical xylose, and open tank. Then second, the aeration system in xylo reactor blow from dash through the composting material. So xylo is what? Vertical type of composting. Horizontal type is horizontal drum. Vertical type is called xylose. We have discussed in the last diagram also. Xylose are the vertical system. How the air is passing through the composting material from the top of the xylose, or from the center of the xylose, or from the base of the xylose, or through 1/4 of the xylose. As I mentioned, always aeration should be happening in the direction opposite to the material feed. If the material in the horizontal tank, if the material is coming from the left side, then the aeration should happen through the right side. And if the xylose, if the material is fed from the top, then the aeration should happen from the bottom. So answer is base of the xylose is correct. So you can see in the diagram also, xylose, the composting material is material to be composted was fed from the top, and aeration is happening through the bottom. So answer is base of the xylose. Here also you can see in the second point. In the second point, the aeration system blows air from the base of the xylose through the composting material. So then only it will, here also raw material will coming from the top, and then aeration is happening from the bottom. Then only what is happening? The mixing of oxygen with the compost will happen. The organic material will happen rapidly or effectively. So third question: in which environment aerobic microbes decompose the waste quickly? Warm and moist, arid climate, cold and moist, hot and dry. This also we have discussed during factors. Somewhat tricky question. Yeah, warm and no, moist in the sense cold and moist or warm and moist. Okay, I'll go with option A, warm and moist. Here you can see in the in-vessel drum composting system, in warm and moist environment, that's what I have mentioned, the good optimum environment required for the aerobic microorganism to degrade flourish and decompose the material at a quicker phase in the inversal composting. Inversal composting will turn, it will, because it's closed environment. Closed, it will create a warm and moist environment for the rapid degradation of the organic matter by the aerobic microorganism. Okay, because aeration is also happening from the top or from sides. So it's an aerobic microorganism. It requires warm and moist environment. It's happening in the inversal composting. So the answer is A, warm and moist. So moving on, fourth question. What are the parameters that needs to be considered during composting process? Final compost should be without foreign matters, high amount of trace elements, low maturity, does not contain humic substances. No foreign matter, that is correct. What about humic substances? Humic substances may be okay. So does not contain humic substances because the compost should have a humic substance. Whatever the decomposed material which will be the product of composting process, that is called humic substance. So compost will have humic substances. So option D is also wrong. A is correct. So this is the properties of a good quality of a compost. Well matured, no foreign matter, low trace material, good physical and chemical characteristics. It will contain humic substances and no pathogenic microorganism, no organic contaminants. That's all the quality of good compost. That's correct. So this is again a multiple choice question. What are the chemical parameters analyzed during composting process? Water holding capacity, soil BOD, pH, electrical conductivity. They are asking about the chemical parameters. pH, EC, yeah, that's correct. SBOD is biological parameter and water holding capacity is physical parameter. Okay, pH and EC are chemical parameters. Okay. So upon mixing with compost, the water holding capacity of the soil increases or decreases or remains same or none of the above. Whenever the final compost is mixed with the agricultural land, the water holding capacity of the soil, how it will decrease? The aim is to increase the water holding capacity. That's why we are adding compost to the soil. So while mixing the compost to the agricultural soil, the water holding the porosity will increase, the voids will increase, the water holding capacity will increase because the area absorption area will increase. That's the because the compost is very fine and very light, so it will increase the porosity, water holding capacity, and void ratio. This is very important. Water holding capacity is higher, then only the plant can absorb more moisture. Plant growth will be higher. That's the ultimate aim. So increasing the water holding capacity. Please check into it, sir. Seventh question. This is again the same question. Being finer, the compost increases the void ratio, porosity, and absorption area. Okay. What is the optimal pH range for microorganism in the compost? That is again 5.5 to 8. Okay. So this we have already discussed. Yeah. So thank you so much for joining. We came to the end of the session. If you have any doubt, please post it in the chat box or you can unmute and you can ask. I'll be here for next 5 minutes. Those who not have any questions, you can leave the meet. Thank you so much for joining.
Thank you very much, sir.
Yeah, thank you so much, sir. Please be remind to attend the assignments by end of tomorrow. Every Wednesday you have to do the assignments. For week 7th assignments, tomorrow is the deadline. Please do the assignments as well. We crossed half of the session, I guess. Yeah, in 12-week course, we have already crossed the 7th week. Yeah.
Good evening, sir.
Yeah, yes, sir, please.
Sir, I am Ruman from Malnad College of Engineering, final year civil student.
Sir.
So, sir, I would like to connect with you after this session. We are working on this water hyacinth, sir.
Water, sorry?
Regarding water hyacinth.
Water hyacinth, okay. For composting
Yes,
only?
Sir, it might be, sir. We are finding a way to reduce the water hyacinth growth, sir.
In the lake or pond, like that?
Yes, sir.
Okay. You can connect with me, but I am not directly related to water treatment or this kind of, but that may be related with solid waste. So you can also connect with me. Also, I will refer some of the papers and let you know.
Definitely, sir. Sir,
Yeah,
the
yeah.
provided number on the screen is yours only,
Yeah, it's
sir.
mine and the email ID is also mine. You can connect, no issues. It's my WhatsApp
Definitely, sir.
number. Yeah.
I would connect with you, sir.
Thank you. Thank you so much. No
Thank you.
issues. So if you have any doubt, you can post it in the chat box or you can unmute and you can ask.
Sir, when is the next session, sir?
Every Tuesday, 6 to 8.
Every Tuesday, 6 to 8. Okay.
Yeah. You can get the mail also from NPTEL.
Oh, yes, sir.
This is your
So,
first session.
this is my third, sir.
Okay, okay, okay.
Third.
And other two PMRO scholars are also parallelly taking session for solid waste management course. Maybe I think Saturday, Sundays, I guess. I don't know about that timing. Mine is every Tuesday, 6 to 8.
6 to 8. Okay,
Yeah.
sir.
Hmm. Yeah. Hope you have no more questions. I'll wind up the meeting. Thank you so much for joining. We'll meet next week. Thank you so much. I'll end the meeting.